Welcome to What's Behind It All, God, Science, and the Universe. My name is Karen Stiller, and I will be your host of this evening's event. Thank you for joining us here in Convocation Hall at the University of Toronto, and welcome to those joining us over the live stream from France to Oregon and many points between. And a warm thank you to the sponsors of this Religion and Society Series event, Wycliffe College, Faith Today magazine, the Center for Inquiry, Power to Change, Ravi Zacharias International Ministries, and the Network of Christian Scholars. I would especially like to thank our speakers this evening, Dr. LaWReNcE KrAUSs, Dr. Stephen Meyer, and Dr. Denis Lamoureux. Let me walk you through what tonight will look like. Each speaker will begin with a 25-minute presentation. At the end of all of those presentations, each speaker will have 5 uninterrupted minutes to respond to what they've heard. We'll then enter into a period of coffee house-style dialogue. That means the speakers pretend they are friends out for coffee, maybe have an argument, and we get to listen in. Then it's your turn to send in questions from right here in the hall or from wherever you are in the world. And in fact, you can send your questions in during the entire evening. And in fact, we have received a few already. By email, scienceversusgodtoronto@gmail.com. On Twitter, #ScienceVersusGod. And here in the hall, you have the option of using the phone number you should have received when you came in to text your question. Following this, we will all need a beer. There will be a reception at Wycliffe College, 5 Hoskin Avenue, following the event, and everyone is welcome. Now let's introduce our first speaker. Dr. LaWReNcE KrAUSs is director of the Origins Project at Arizona State University and foundation professor in the School of Earth and Space Exploration and the Physics Department at ASU. He is co-chair of the board of sponsors of the Bulletin of the Atomic Scientists and on the board of the Federation of American Scientists. He has won numerous international awards for both his research and his efforts to improve the public understanding of science. Dr. KrAUSs is the only physicist to have received the top awards from all 3 U.S. physics societies and is the author of 9 books, including bestsellers, The Physics of Star Trek, and A Universe from Nothing. And he spent last Saturday evening in conversation with Johnny Depp at his Origins Project dialogue. His newest book, The Greatest Story Ever Told So Far, comes out next year. Dr. KrAUSs appears regularly on radio and TV and is executive producer and subject of The Unbelievers, a documentary film that discusses science and reason. Dr. KrAUSs, welcome.
Thank you. Thank you. Thank you. Thank you. Thank you very much. Is this working now? Thank you very much. Thank you for the kind introduction, and thank you for the organizers of this. I'm going to take a little bit of time, and I have very little, but I'm going to take a little bit of time clearing up a misconception. I noticed the Discovery Institute has been tweeting this like crazy and promoting this event because the Discovery Institute, in case you don't know, is a rather moribund right-wing creationist group, which Dr. Meyer is a part of. And they were very excited that I agreed to do this because if you appear on stage with someone talking about these things, it gives the impression that the ideas are worth debating or that the person is worth debating. In this case, neither is true. I just want to make that quite clear because Steve Huko, wherever he is, there you are, and the people here at Wycliffe were very, very nice and asked me to do this a long time ago, and I discovered afterwards who was on, and I decided that for their sake I would do it. I'm going to continue to disparage Stephen for a little bit. He seems like a very nice man. He told me he's a very good father, and I believe that. But nevertheless, the organization he works for, when the last time we met, as I recall, was about 15 years ago when he came to Ohio, where I was trying to defend the teaching of science, and he came as part of the Discovery Institute program, and we spoke before the school board, where they were advocating the introduction of intelligent design in the classroom. And Stephen did a brilliant advertising move at the time, which was to surprise us all by coming up and say, we're not advocating you teach intelligent design. We just want you to teach the controversy, which itself was also a lie, but it sounded much better. And I want to just tell you a little bit about this, because Stephen will, I know, come across as a interested scholar, and I want to disabuse you of that right away. So, so he leads a group that used to be called the Center for the Renewal of Science and Culture. It's now the Center for Science and Culture. And this was their mandate in 1998. They've taken it off since then, but the proposition that human beings are created in the image of God is one of the bedrock principles on which Western civilization was built. This cardinal idea came under wholesale attack, drawing on the discoveries of modern science. Science is bad. Discovery Institute's Center for the Renewal of Science and Culture, renewal has now been removed, seeks nothing less than the overthrow of materialism and its cultural legacies. Then there was a wedge strategy, which they began Institute in 1998, and Ohio was the first place where they did it in 2003. It was to defeat scientific materialism and its destructive moral, cultural, and political legacies, because science, of course, is evil. To replace materialistic explanations with a theistic understanding that nature and human beings are created by God. And 5-year goals included to see intelligent design theory as an accepted alternative in the sciences and scientific research being done from the perspective of design theory, and to begin attacking science teaching in the public schools, which is what they began in Ohio. And it was reprehensible then, it's reprehensible now, but the good news is we don't have to talk anymore because it's a done deal. The case is closed. Now, let me just explain to you why the problem here, that one of the reasons why it was dishonest. Because, it's okay to make a proposal. There's no problem in arguing that perhaps things are intelligent design. That's a reasonable thing to ask a question of, and it's even a reasonable thing to think about. But it's not a reasonable thing to put in the high schools. Because here's the way things are normally done. You make a novel scientific claim. Well, most of my colleagues don't even make novel scientific claims, but they make scientific claims. We all sort of make little baby steps. And then we do research. It's called research. You actually try and actually prove it right, but you also try and prove it wrong. And if it comes out that you can't convince yourself it's wrong, then you send it out for peer review, which means you go out and then they send it to a bunch of idiots who tell you why it's wrong, and then you argue with them for a long time, and then maybe you're lucky enough to get it published. That doesn't mean anything. Publication doesn't mean anything. But if it's interesting, you build a scientific consensus, and then, and only then, 20 years later, does it get into the schools. Okay? But what they were advocating at the time was just skip all the intermediate steps. Just go right to the schools. And that's a disservice. It is child abuse. Okay. But happily, okay. See, this all ended happily a little over 10 years ago in Dover when the Dover school system wanted to try and basically teach the controversy. And you should read the judge's statements on that. I won't go into it, but basically what the school did was basically require a statement that, Darwinian theory is a theory, there are gaps, and intelligent design is an alternative explanation. And the judge, who had been appointed by Bush or Reagan, I forget, basically said in his statement, in making this determination, we have addressed the seminal question of whether ID is science. We've concluded that it's not, and moreover that ID cannot uncouple itself from its creationist and thus religious antecedents. And I really like the next one, which was the breathtaking inanity of the board's decision is evident when considered against the factual backdrop which is now being revealed through this trial. So the inanity of intelligent design was over, and that sort of put the Discovery Institute away for a little while, and that's why I think they're so happy to have this oxygen, which unfortunately you all in you decided to give them. Anyway, so it's not easy to do that to someone on stage. I want you to know that, but it's not. But the point is, what you'll hear often over and over again then is what the problems are with science, and it's a rotating story. I was going to say it's a good example of evolution, but it's not. It's adaptation. But every scientific claim, my ideas about evolution, and I'm going to let my esteemed colleague probably talk about that in a second, has been proven wrong. First, there wasn't a genetic relationship between humans and chimpanzees. That was proved wrong. There was a claim there was a non-existence of transitional fossils, but every time we've looked for a transitional fossil, generally we found one. There was a little molecular motor, which they talk about a lot, and it's impossible to evolve, and of course that's been shown to be nonsense. there was an issue about their blood clotting, which requires a lot of intercedence, could evolve, and again, that's been demonstrated to be wrong. More recently, I think Stephen wrote a book about the Cambrian explosion, claiming it was impossible. And then, of course, if you read, say, reviews in Science magazine, you'll find out why the science of that was wrong, and I don't know if you're going to talk about it. Maybe you will. I don't want to. But the point is, it's all been shown to be flawed. So you'll just, every time one thing goes down, you'll find another. And the point is not that there's interesting science to discuss. The point is to try and find something else that you can do to pretend that there's a controversy when there isn't. Now, after they lost with biology, what I noticed is that cosmology is next. And I'm hoping for his own sake that Stephen doesn't try and do that here while I'm here. Because it'll be a mistake, I promise. But now, I just met Denis, who's a wonderful man and an honest man, it seemed to me from listening to him. But nevertheless, I think misguided. And in the sense that I watched an event for you. And the two things I want to say is that you said that you've experienced miracles and that the Bible is the Word of God. Those are two things you believe, which is fine, but my statement would be, prove it. And in particular, as Carl Sagan borrowed from someone else, but extraordinary claims require extraordinary evidence. And I can't think of two more extraordinary claims, and for which, as far as I can see, there's no evidence whatsoever. So we'll hear about that, but that's where I'll disagree with Dr. Lamoureux, because I think you have 3 doctorates, I think. And I only have 1 if you don't count honorary degrees. Okay, so the guiding principles I want to do, I'm going to be fast here, okay, because I took a lot of time with my disparaging, but I think it's probably as important as anything else, especially for people listening out there. But the first thing is, do not assume the answers before you ask the questions if you want to make progress. And by the way, that's what I think ultimately religion does. You assume the answers. You assume the Bible is the Word of God. You assume that scientific materialism must be evil or wrong because somehow it might attack your faith. What we have to do is our belief should conform to the evidence of reality, not vice versa. So that's rule number 1. Rule number 2 is that the universe is the way it is whether we like it or not. And it may not seem very nice. In fact, some of the things I'll argue about seem pretty rotten or confusing or nonsensical. But it's up to the universe, not us, to decide what makes sense. And the last one is, this is really important, because this you'll hear of a lot. The lack of understanding is not evidence for God. It's evidence of lack of understanding. Okay? And that's really important. Okay. So, next few minutes, so the question is what's behind it all, and the first thing I want to do is point out what it is, which is nothing. And I want it nothing in a variety of ways. Now, I figured there might not be a lot of content, so I'm going to spend 5 or 10 minutes doing some physics, because at least there'll be some content. So I want to tell you about the universe we live in, and the rest is just talk. So this is a picture of part of the universe we live in. It's an amazing universe. There are over 100 billion galaxies in the observable universe. This is actually a multi-chromatic image from the Hubble Space Telescope Deep Field. So every dot in this image, except for that star there, is a galaxy, not a star. And there are 100 billion galaxies, each of which contain 100 billion stars or so. And the most distant galaxies here in this picture are probably 9 billion light years away. That means it took 9 billion years for light to get here, which means it left those stars well before our sun and Earth formed, because except for all the Republican candidates in my country, the Earth is 4.5 billion years old. But that means that since the average lifetime of a main sequence star is 10 billion years, many of the stars in this picture no longer exist anymore, and the civilizations that may have existed around those stars, that may have invented their own myths, are long gone. And if they took a picture of us, by the time the image, right now, by the time the image got there, our civilization would be long gone, our sun would be burned out, and all of the petty trials and tribulations and debates about ID or science will be gone, because the universe doesn't care about us. Okay. Now, here's the universe. So you see it. The main thing is, it was 1929, Hubble discovered that the universe is expanding. That changed everything. That meant it had a beginning, at least our observable universe. And that changed everything. It was quite theistic in a way, in a sense, because science up to that point had assumed the universe was eternal. And so what we notice is all galaxies are moving away from us. These are galaxies, not sperm, because this is a physics talk. So that meant the big question then becomes, is it going to collapse? And then it turns out, due to general relativity, we need to know the geometry of the universe to determine the future, which is the reason I got in the business as a particle physicist, because I wanted to be the first one to know how the universe would end. It seemed like a good idea at the time. But the point is, depending upon how much matter there is, whether the universe is open, flat, or closed, as you add matter, an open universe becomes flat and then closed, and these are two-dimensional images of what are really three-dimensional universes, but we can't picture them. The future of the universe would be different. And so we spend a lot of time trying to determine the total density of matter in the universe and the geometry of the universe. And I would love to be able to spend more time telling you about it, but I'll give you one picture, because a picture is worth 1,000 words, of how we measure mass. This is an amazing thing. This is what science can do without bias or prejudice, is to look out and see a phenomena that Einstein predicted in 1937, but never said would never be seen. This is a cluster of galaxies about 5 billion light years away. And what you can see is these weird blue things, and what these weird blue things are multiple images of a distant galaxy 5 billion light years behind that cluster. A galaxy that would not be visible if space itself wasn't curved and didn't act like a lens and magnified that image and produced multiple images, because Einstein told us that matter curves space. Well, that means you can actually use this to weigh this system. You can ask, how much matter could there be in this system, and where would it be distributed in order to cause that picture? This is a cluster of galaxies. Clusters are the largest bound objects in the universe, and therefore, if anything falls into them, if anything's there, it'll fall into them, and we can weigh the universe, determine the total amount of matter by weighing clusters. And this is one way to weigh this cluster. The peaks, if you do that, if you do what's called the mathematical inversion and find out where the mass is, you'll find the peaks here are where the galaxies are, but you notice there's a huge mountain of mass where the galaxies aren't. Most of the mass in the universe is invisible and dark and made of something else. And ultimately, we determine the total amount there is. It's this number here. We give it a Greek letter because, like theologians, we like to sound scholarly. And the number is 0.3, which means that the total amount of matter in the universe is 30% of the amount of matter to make it closed, to make it flat, to make it exactly flat. Now, in fact, that was a problem because there were many reasons to believe the universe was flat, and I don't have time to tell you how, but in fact, we have discovered in the intervening 15 years, the universe is precisely flat. There's just enough energy to make the universe flat, but if there's only 30% of the amount of matter needed to make the universe flat, where's the rest of it? Nothing. Because if you put energy in empty space, if you take a region of space and get rid of all the particles and all the radiation, get rid of everything, and if space still weighs something, it does something strange. Most of you who've gone to school know that gravity sucks, okay? But it doesn't. It can also blow. And if you put energy in empty space, gravity blows. It's repulsive. And what was discovered by a group of astronomers, although some of us had predicted it earlier, but no, they didn't believe us, is if you look at the expansion of the universe, this is the velocity of the universe as a function of time in some sense. If this curve turns up, the universe is actually speeding up. And what was discovered, they expected to find the universe slowing down, because any sensible universe should slow down over time. But they discovered to their amazement in 1998 that the universe is speeding up. And if you had to ask how much energy do you have to give to empty space to make the universe speed up, you got exactly what you're missing. 70% of the energy of the universe resides in empty space. 70% of the universe resides in energy empty space, almost 30% in dark matter, and we are just the little bit left. We are irrelevant to the functioning of the universe. That's a key point. We are a bit of cosmic pollution in a sea of dark matter and dark energy. The visible universe, everything we see, is largely an irrelevant sideshow. So much for a universe made for us. In particular, if you got rid of everything I showed you in that picture, everything we see in the night sky, everything in the universe that we can see, the universe would be essentially the same. As far as the dynamics of the universe is concerned, us and everything that we value in this room is completely irrelevant. And I'll argue that's wonderful. Okay. Now, here's the neat point. It turns out a flat universe, the gravitational energy of every object in a flat universe is zero. That was the first indication that something interesting is the case. Because if you were going to create a universe from nothing, what would you make the total gravitational energy of every object? It means you can have essentially the ultimate free lunch. Because gravity has negative energy as well as positive energy, it may seem like it requires a miracle to create a universe and to create 100 billion galaxies, but the laws of physics allow it to be done without any cost of energy. You can start out from nothing and end up with a universe that's populated. In particular, empty space is not so empty. The laws of quantum mechanics tell us that it's a boiling, bubbling brew of virtual particles. When you have gravity in, it means if you wait long enough, empty space with nothing in it can start to produce particles. It won't violate any laws of physics, but it gets better. Because when you allow quantum mechanics and gravity to come together, that allows then space and time, which are the dynamical variables of general relativity, if they become quantized, then they start to fluctuate too. And that means you can have your whole universes fluctuate into existence, pop into existence, and pop out of existence. And the only universes that might survive for a long time are ones with zero total energy. So keep that in mind. And it's something that's important I'm going to talk about in a second. It's not just space, it's also time that pops into existence in this picture. Now, if you ask what would be the characteristics of a universe which spontaneously arose from no universe, no space, no time, no matter, no radiation, the amazing thing is that it's precisely the characteristics of the universe we live in. It didn't have to be that way, because this is science. It could have been wrong. It could have been wrong, and it wasn't. Okay, that's very important. In particular, science has demonstrated, and I obviously don't have time to do an adequate job here, that creation of a universe full of matter from no universe at all is not only plausible, but likely, and requires no supernatural shenanigans. Okay? So that's what science has told us. Yes, it's worth celebrating. It's worth celebrating. I may actually finish on time. I'm amazed. Okay, so that's two options now. When people talk about creation, it gives a lot of room for people like Steve and other people to say, okay, there's creation, who created it? What's the cause? What's the cause? What's the cause? The first answer is, there may be no cause. Not only just because things rise spontaneously in physics, there's no cause for the photons of that light to leave that light when they do. You can't predict it. There's nothing that determines when each photon will be created. But it's something much more fundamental than that. If time arose at the Big Bang, there was no before. If there is no before, then there can be no causal relationships at that time. And that's very upsetting, because we don't understand that. We don't understand how to deal with a system that doesn't have causal relationships. But who cares? It may be that way, and we may have to force our thinking to evolve to try and understand a system where there are no causal relationships. We don't get to choose. So these classical notions of cause and effect may go out the window. Some people don't like that, because they say you're changing the rules. We call that learning. Okay. Now, the other possibility is that our universe is not, there is a global time, and our universe just created out of something else, which we now think of as called a multiverse, and it could be that our universe arose 13.8 billion years ago in a system in which there are many universes, some of which are just coming into existence now, some of which are collapsing out of existence. That's certainly possible, okay? But in that case, once again, there need be no cause. Our universe can spontaneously pop out of the universe. In fact, we have a theory that tells us exactly how that can be the case. And our universe in that case is no more significant than an icicle on a window. An icicle, and you know about that in Toronto, an icicle on a window forms because of some seed, some perturbation that causes ice to form there and not somewhere else. A complete accident. And in that case, our universe can be a complete accident. And everything in our universe a complete accident. That's certainly possible. And in fact, I would argue is plausible. I put this up because gravitational waves are so neat, and everyone's been asking me about them. I put this up, and I wish I had time to talk about it, because it's more interesting than God. Because it has content. But most importantly, what I said sounds like metaphysics. And I don't do metaphysics. I mean, I might think about it. We all do, okay? But what's really neat is if we measure gravitational waves, not the ones that have been discovered 2 weeks ago, but gravitational waves from inflation, we will measure, in principle, be able to get incredible indirect evidence about the existence of other universes. Evidence which is as overwhelming as the evidence in 1905 that atoms existed before we'd ever be able to say we saw atoms. So we can make this science, and that's what's really important. Okay. Now, one of the other arguments that's given, and you'll hear about potentially, because I hear about it all the time, is that the universe is fine-tuned for life. Let's get this straight. It isn't. It isn't. Life is fine-tuned for the universe. It's exactly like bees and flowers and the design that seems apparent in evolution. It looks like we're designed. But in fact, bees couldn't, if they didn't see the colors of flowers to get nectar, they wouldn't reproduce. So in fact, it's not that they're designed to do that, it's that it's natural selection. But in this case, the universe can have many different characteristics, and it's not too surprising that we have precisely the characteristics that allow us to live in this universe. Now, that would be a neat debate to have. How can we live in a universe in which we couldn't live? Now, that would be worth having a debate about. But we don't have to, because we evolved in a universe which had certain characteristics. If the universe had different characteristics, who knows what life forms could have evolved? The argument is exactly ass backwards, because it's exactly like saying, isn't it amazing that my feet have exactly the right length to reach the ground? Exactly. Look, it's amazing. Okay? Okay, you get the point. The point is also, and I don't have time to talk about this, if you look at the long-term future of life, we actually live in the worst of all possible universes. First. Secondly, most of the universe is completely inhospitable to life. If you wanted to design a universe that was good to live in, it would not be the universe we live in. We live in a very rare place in our universe, and even then, the universe is trying to kill us every single day. And it will. It will destroy life on Earth at some point. It's inevitable. Most of the universe is unbelievably not fine-tuned for life. It is an awful place to live in most places, and in this place, it will be an awful place to live. It's a momentary respite. And if you have a big universe with 100 billion galaxies, 100 billion stars, you're bound to find some places where life can evolve. It's not too surprising, then, to find that life evolved in those places. It's not evidence of design. So the key point is, what's behind it all? The really important answer is we don't have the slightest idea right now. And that's worth celebrating. We have a lot of plausible notions, but the reason we do science is to try and find out. We don't assume the answer before we ask the question. Oh, okay, I want to talk about this. So this is the point. This was from the judge's ruling in Dover, and I think it applies more generally. The fact that a scientific theory cannot yet render an explanation on every point should not be used as a pretext to thrust an untestable alternative hypothesis grounded in religion into the science classroom or to represent well-established scientific propositions. We don't know the answer, but that doesn't give room for that. Okay. I remind you, yeah, I'm going to try and be close. So these are my 3 principles that I talked about. And let me just say, what I've shown you is that it's perfectly plausible to make a universe without God. Does that prove there's no God? Absolutely not. But it makes the hypothesis even more redundant and unnecessary. It's an amazing claim without evidence, and now without necessity. We know that there are plausible routes to do it without God. It also lacks any explanatory or predictive power. As an explanation, it's useless. It's a doctrine, not an explanation. Not supported by any data. And the final thing, and I think it is the final thing, so you're at 0 and I'm almost ending, but I would go on if I was, so it doesn't matter. But I want to point out the last thing. Let's say you're a deist. Let's say, you know what, and there are colleagues of mine who are, and the colleagues of mine who are very religious in many ways. But let's say you say, look, you know, there doesn't look like there's any purpose to the universe, but I think there probably is purpose. The laws of physics have some order, and I think there may be purpose behind the universe. Okay, look, maybe there is. There's no evidence of it, but fine. But that is vastly different. There's no rational way to go from there to any of the world's religions, all of which are incompatible in their doctrine and their sacred books with the evidence of reality of science. So you can be a deist, and that's okay, because that's not inconsistent with science, but to accept any of the world's religions, you ultimately have to close off half of your brain. And that what we should, instead of doing that, we should celebrate that we are not. It may seem that a universe in which we are insignificant and the laws of physics are cruel is bad. But instead, we should celebrate that we are not subject to the rules of some Saddam Hussein in the sky, who doesn't just punish people he doesn't like for their lifetime, but decides to punish them for all eternity. Instead, we should celebrate that we can make our own mistakes, we can make our own worth, we can make our own meaning, and we can make every second we breathe more worthwhile by enjoying the wonder of the universe in which we live. Thank you very much.
Well, even though he did go over time a little bit, it's always good to hear the word shenanigans used in high academic debates, so thank you very much. We now turn to Dr. Stephen Meyer. Dr. Meyer is the director of the Center for Science and Culture at the Discovery Institute in Seattle, Washington. He received his PhD in the philosophy of science from the University of Cambridge. He is a former geophysicist and professor and author of New York Times bestseller, Darwin's Doubt, The Explosive Origin of Animal Life and the Case for Intelligent Design, as well as Signature in the Cell, DNA, and the Evidence for Intelligent Design, which was named a Book of the Year by the Times of London Literary Supplement in 2009. Dr. Meyer's research addresses the deepest mystery surrounding the origin of life and the origin of animal life, the origin of biological information necessary to produce it. Dr. Meyer has also published in newspapers such as the Wall Street Journal, USA Today, the National Post, the Daily Telegraph of London, and the Los Angeles Times, and appeared on multiple national television and radio programs, as well as featured in 2 New York Times front page stories. In 2008, he appeared with Ben Stein in the documentary Expelled, No Intelligence Allowed. He has also been featured in the documentaries Icons of Evolution, The Case for a Creator, Darwin's Dilemma, and Unlocking the Mystery of Life. Dr. Meyer, welcome.
You get the laptop. That's not good. Yeah, let's try it again. I'm trying to get back. Yeah, I'm trying to get back to PowerPoint. There we go. It was perfect before.
Oh, you know what? You haven't got plugged in.
Yeah, I know, but I'm trying to get the right guy up. But thank you. Ta-da. Hey, it's nice to know a guy who can say so many unpleasant things about you is also willing to help you with your PowerPoint when it breaks down. Yeah, very Christian. Yeah, very good. Yeah, I was going to say I was really looking forward to the conversation, but maybe I won't say that now. So. I do want to say that it's an interesting way that Professor KrAUSs started, because you may have noticed he didn't actually critique the theory of intelligent design. To do that, he would have had to explain what it is. So maybe if you just wedge your minds open a little bit after all those unpleasant things you heard, I'm going to tell you a little bit about what it is, and then you can evaluate it based on my presentation. I love the title of our event, What's Behind It All. It's really a great way to think about what we're talking about tonight, because, by the way, I'm not here also, was billed as a science versus God debate. I'm here defending a theistic view of science. I'm not opposed to science, and but I'm defending a theistic view of science rather than a strictly materialistic view of science, where these are understood to be competing worldviews. Professor KrAUSs' sidekick, Richard Dawkins, said something very interesting that connects to the theme of this event. He says that biology is the study of complicated things that give the appearance of having been designed for a purpose. And I will come back in my 5 minutes to talk a little bit about some of the things that Professor KrAUSs said about cosmology, but this talk is going to be about the biology and what might lie behind it. Dawkins' statement here is very provocative because he's saying there's an appearance of design in living things. And this is a long-standing perception of many biologists. What Dawkins says, though, lies behind it is instead an unguided, undirected process, namely natural selection acting on random mutations and variations that has the power to mimic the capacities of an intelligent mind without itself being guided or undirected in any way. That's the famous natural selection random variation mechanism. Now, there are lots of things that do give this appearance of design in biology. The discernible architecture of an animal body plan, the intricate organs such as eyes and hearts and things that we find in the world of mammals, the intricate circuitry, genetic circuitry that we are now discovering that controls animal body plan development. And yes, these amazing miniature machines that are being found in cells, including the now famed bacterial flagellar motor with its many protein parts, rotor, stator, bushings, drive shaft, etc. But from a biological standpoint, whether you accept Dawkins' explanation or not of apparent design, all biologists recognize there's something that lies biologically underneath all these appearances of design. And it is the information necessary to build these exquisite structures. And we now know about where a lot of that information is stored. A lot of it is in DNA. We're finding that it's also stored in other places in living organisms. Now, just looking at that intricate motor from a minute ago, and then look forward to, this is one of the parts of that motor. The motor is made of proteins. The proteins are made of subunits called amino acids. And to get the parts of the motor to fold into the right structure, three-dimensional structure, the amino acids of each protein have to be sequenced properly. And that's where DNA comes in. DNA provides the instructions for arranging the amino acids that cause the proteins to fold into three-dimensional shape, that allow proteins to do all the amazing jobs they do in cells. They catalyze reactions, they process information, they build the structural parts of intricate machines. Now, our appreciation of what DNA does, of course, started with the discovery of its structure in 1953 with Francis Crick and James Watson. And this was the famed double helix structure that we all learn in biology. But I think even more significantly was the recognition by Francis Crick in 1957 of the digital character of the information that's stored in the DNA molecule. This is his famed sequence hypothesis. Crick argued that the four characters, or the four chemical subunits that run along the interior of the molecule, called nucleotides or nucleotide bases, function just like alphabetic characters in a written text, or we might now compare them to digital characters in the section of machine code or software. Now, this was mind-blowing because it really initiated the information age of biology. I used to ask my students a question when I was teaching. If you want to give your computer a new function, what do you have to give it? Code, software, instructions, all those are correct answers. And this is the great insight that flowed out of the molecular biological revolution of the late 1950s and into the 1960s. That inside if you want to build a new protein or a new animal or a new organ or a new body plan, you've got to have new information. It's just as in the computer world. So for example, if you want to build a new Cambrian animal, you've got to have new cell types. But each cell type requires dedicated proteins. For example, maybe a new animal would have a gut. Gut would require a digestive enzyme. An enzyme is a type of protein, so you need a new protein. So to build that new animal, you've got to have new cell types, new proteins, but the proteins, in turn, need the instructions in the DNA that are stored in DNA, and we're now finding that there's other layers of information in living systems as well. Now here's the extraordinary thing in relation to Dawkins's concept of apparent design, which, by the way, is classical Darwinism. That goes right back to Charles Darwin himself. That this machine code, this informational, the information stored in DNA is a striking appearance of design. Dawkins himself calls the machine code of the genes uncannily computer-like and compares it to what you might find in a computer engineering journal. He goes on to say in a more recent interview that genetics has become a branch of information technology. It's pure information, it's digital information, it's precisely the kind of information that can be translated digit for digit, byte for byte. He goes on to say that Darwin would have been fascinated by the discovery of the information at the foundation of life, and maybe he would have been. But it also turns out that evolutionary theory has been unable to explain the origin of this information. This is because it's been the information at the foundation of life has turned out to be a difficult thing to explain for two different branches of evolutionary theory. Chemical evolutionary theory, which attempts to explain the origin of the first life and the information required to build it from simpler non-living chemicals, and biological evolutionary theory, the origin of new forms, which attempts to explain the origin of new forms of life from simpler pre-existing forms of life. In both cases, by reference to the principle I just outlined, you need new information to build new biological form, whether we're talking at the one cell level or at the multicellular level of a new body plan. Now, why is the origin of information a difficult thing to explain? Well, one of the first things we need to understand is the kind of information we're dealing with. We're not talking about information in the purely mathematical sense of Claude Shannon, the famed information theorist or founder of the same. Shannon's equations equate information and improbability, or that's to say, the more improbable a string of characters, the more Shannon information it has. The information in DNA has Shannon information. It's an improbable arrangement of chemical subunits functioning as informational characters. But in addition to mere Shannon information, mere improbability, or it's a synonym for that is complexity, what we have in the information in DNA is specified complexity. Improbability of arrangement, where the arrangement also matters to the function of the string, this function that the string, the string performs. So DNA information is much more like the lower string, not the higher string, okay? Where there's clearly a function, a communication function involved. Now, why does that then become a difficult thing to explain from an evolutionary point of view? Well, we have a good analog to that in our own experience. Anyone out here written any computer code? If you have a section of functioning code and you start to randomly change the zeros and ones, are you more likely to degrade the information that's there already or generate a fundamentally new program or operating system? Obviously, the rhetorical question has its own answer. You're going to degrade the information. And this has to do with the specificity of the sequence and also a mathematical fact about it. And that is this, that there are a lot more ways, when you're talking about functional information, there's a lot more ways to arrange characters to go wrong than there are that will allow the characters to perform a function, to go right. So, 1960s, there was a conference at the Wistar Institute. And there was some leading MIT physicists, engineers, computer scientists who were some of the first scientific skeptics of the neo-Darwinian synthesis. And they had mathematical reasons for this. And it had to do with just this very fact. in Murray Eden's words, that no currently existing formal language can tolerate random changes in the symbol sequences which express its sentences. Meaning is almost invariably destroyed. Now, there's a reason for that. And that reason has to do with the math. I've got a way of illustrating. A combination lock. If you got a combination lock with 4 dials on it, and each dial has 10 digits, how many different possibilities are there? Because we're all tempted to say 40, 10 plus 10 plus 10 plus 10. But of course, that's the wrong answer. It's actually 10 times 10 times 10 times 10. That's 10 to the 4th. That's 10,000 possibilities. And that's why the lock works. There's a lot more ways to go wrong than right. So if you want to search for the correct combination that's going to open the lock, perform a function if you're a thief, you are overwhelmingly more likely to fail than to succeed. A random search is more likely to fail than to succeed. Unless, of course, what? Unless you've got a lot of opportunities to perform that search, okay? Now, I was bored this morning, worked it out. If the thief, let's say there's a thief outside the auditorium, he sees a bike, he wants to figure out how, he wants to crack the code, crack the combination. If he's especially diligent, he turns one dial every 10 seconds. In a little over 14 hours, he can get to 5,001 combinations, which means at that point it would be more likely that he would succeed than he would fail. In which case, the hypothesis of a successful random search might be more likely to be true than false. But what if our thief faced a lock like this? With 10 dials, not 4 dials. Now how many possibilities are there that need to be searched? Well, now the number increases dramatically, exponentially. It's 10 to the 10th, or 10 billion possibilities. So now let's say we've got that same exceptionally diligent thief, but he wants to, but he starts spinning. He's not mathematically literate, and he ends up devoting his entire 100-year life to it. I did the same math. Turns out that in 100 years, if he does nothing but search those dials, he's going to search no more than 3% of that entire, all those possibilities in his entire life. So now ask yourself a question. Is it more likely that the thief will succeed or fail in a random search of the total number of possibilities? Obviously, it's more likely that he'll fail. He can't sample enough of the total space to have a reasonable chance of succeeding. It's going to be overwhelmingly more likely that he'll fail than he'll succeed. In which case, the hypothesis that he would succeed is going to be more likely to be false than true. Now, this all applies to life because DNA and proteins are also combinatorial systems. They can be likened to bike locks. There's lots of possible ways of arranging those A, C's, and G's and T's along the spine of that DNA molecule. And consequently, there's a really important question that has to be answered, which is how rare or common are the functional sequences among all the possible ways there are of arranging the A, C's, G's, and T's in DNA and the amino acids, the corresponding amino acids in the proteins. Because proteins are also, can be thought of like a lock, 20 different possibilities at each site. So critical question. How rare are the functional combinations? Are they like, for example, the first lock, where with a reasonable amount of time you could search and eventually find the ones that are needed? Or are they more like the second lock, where there is simply not enough time available to have a reasonable chance of searching the entire space to make it more probable than not that you would succeed, and making a random search hypothesis more probable than not to be true? Can I get just a little water while I'm finishing? Yeah. You drink directly from the...
Yeah, because we have a cup of wine.
Oh, that's not yours. I'll take that. All right, sorry. All right, well, I have a colleague who does some of this research that intelligent design people never do, named Douglas Axe. He did a PhD at Caltech, got very interested in this problem because of some work that was being done at MIT, and in which it was initially determined that the functional combinations of DNA sequences and were very rare in relation to the non-functional ones, much more like the second situation of the 10-dial lock, where there wasn't enough time for the thief to search the space. But he wanted to build on this work and get into it more deeply and to clarify some issues. So he did about 14 years of research at Cambridge University to nail down this question using a method known as site-directed mutagenesis. And he determined that, indeed, just like the lock analogy, the ratio of functional arrangements of amino acids to functional proteins, or rather the other way around, the ratio of functional proteins that fold into a stable three-dimensional shape that could potentially do a job in relation to all the possible arrangements of amino acids was very, very small. And based on this very detailed regime of experimental research, he got a number. And it's kind of a scary number from the standpoint of the success of a random search. It's 1 over 10 to the 77. That basically tells you the size of the lock that we're dealing with, okay? It's like a lock with 77 dials and 10 digits, okay? And that's a brute measure of rarity. The numerator is functional sequences. The denominator is all the possible combinations corresponding to those functional sequences. Now, of course, to determine the plausibility of a random, undirected mutational search, you also need to know, again, how many opportunities are there? It's like with our thief out there. Is he very diligent, lots of time, or a limited amount of time? Well, it turns out that that's also a tractable question. And the question turns on whether or not you are basically on how many trials could take place in evolutionary history. We've had 4.5 billion years of Earth history, probably about 3.85 billion years of evolutionary history with life on Earth. And in that 3.85 billion year period, there have been about 10 to the 40th organisms. About 10 to the 39th and change are bacteria, and not that relevant to most evolutionary searches at higher levels beyond one-celled organisms. But even if you include all of those organisms and assume that every time there's a replication event, a new organism coming online, that organism is able to search through random shuffling a new DNA sequence, you're still only going to search 1 over 10 to the 37th power. That's 10 to the 40th over 10 to the 77th power. In other words, you're going to sample 1 10 trillion trillionth of the total possibilities in entire evolutionary time. In other words, this is much more like the second conceptual example where what are called the probabilistic resources are not sufficient to ensure a successful search. And as a result, that means that it's much more likely that such a search will fail, and the hypothesis that such a search is how the information necessary to build new protein folds arose is much more likely to be false than true. Now, so this is one of a number of profound problems with the origin of information. Professor KrAUSs mentioned that my book had been reviewed in Science. Indeed, it had. And I thought the review was extremely instructive because this shows what the best critics of the argument I'm making have been able to say. This is Professor Charles Marshall, a very good paleontologist and evolutionary biologist. He says that Meyer's case depends upon the claim that the origin of new animal body plans requires vast amounts of novel genetic information. In fact, our present understanding of morphogenesis indicates that the new phyla... I'm sorry. I'm having a migraine headache. I don't know if you've ever had that happen, but I'm no longer able to see. Sometimes it triggers for me with the bright lights. Anyway, here's the point. Marshall says that, look, Meyer says you need all this new information to build the new Cambrian animals. But he says that's not our current understanding. All you would need is for these networks of genes that I showed you before, the regulatory networks, these circuits of genes and proteins, to I'm sorry. This has actually never happened to me in a public talk before. I'm really sorry about this. So all you would need is these networks of genes. All you need is for the evolutionary process to re-engineer these networks of genes so that they would, to alter the way they act on other pre-existing genes, okay? So what's Marshall presupposing in this? He's presupposing three really significant sources of information. The networks of genes are called developmental gene regulatory networks. It's actually probably better in the dark, if you don't mind. He's presupposing other genes that these networks act upon, and he's presupposing alterations in the code that would allow for these changes. So in order to answer the argument I'm making about the need for intelligent design to explain the origin of information, Marshall presupposes three pre-existing sources of information: alterations in code, DGRNs, and the genes upon which those networks of genes act, okay? That doesn't answer the argument. That begs the question as to, it just pushes the origin of the information problem back earlier, okay? Now, I got very interested in the problem of, actually, I'm skipping because of the physical difficulties I'm having, but I want to make this other point if I can get through it. This is the problem I've developed or described as a problem that affects biological evolution. At a more fundamental level, there's a problem for chemical evolution. That's how do you get from the chemistry in the prebiotic soup to an information-rich molecule like DNA? And the answer is, well, one answer has been given. You can't invoke prebiotic natural selection. It's hard to do because prebiotic natural selection presupposes that you have organisms that can self-replicate and compete with each other for survival. So what the chemical evolutionary theorists have tried to explain the origin of the information to get life going in the first place directly from the chemistry. And these are called self-organizational scenarios. And what they say is that perhaps there were some chemical attractions, some differential bonding affinities between the different parts of the DNA molecule that explain how the A's, G's, and T's got aligned properly, that explain the origin of the information. They want to explain the information from the underlying laws of chemistry and physics. Now, I'd like you to look, if you can, I can't quite see it myself, but if you look at this, the structural formula for DNA on the screen behind me. You see on each side there's the sugar phosphate backbone. On the inside you'll see that there is the A's, T's, and G's, and those are the subunits of the molecule that are that carry the information. That's the information-bearing part of the molecule, the A's, G's, and T's. Do you notice that the little sticks represent chemical bonds? And in the sugar phosphate backbone, lots of sticks between them. There's a stick connecting each of the information-bearing subunits to the backbone, but there are no sticks, no chemical bonds between the individual units in the information-bearing axis, which means that there is no chemistry determining the arrangement of the characters in the information-bearing axis. Indeed, the bonds between the subunits, the nucleotide bases, and the sugar phosphate backbone are themselves all the same kind of bond. They're called N-glycosidic bonds. So they don't differentiate either. Any one of those bases can attach at any place along the DNA molecule, which is to say the sequence itself is, from a physical chemical law standpoint, completely indeterminate. The physics and chemistry is not determining the sequencing. So that's another reason it's hard to explain the origin of information. I've got a little illustration that I like to use. It's a metallic chalkboard that gets this across. I have a friendly atheist interlocutor, Larry Moran, who got in touch through the organizers and said he wanted to get in touch afterwards. And I was going to make a message to him and said, Moran rocks. But I didn't grab the right letters when I was running out the door the other day. So sorry, that's not so smart, but let's pretend that's an M. Okay, now this message you can see is not produced by the physics and chemistry of magnetic attraction, right? And this is an analog to what's going on in the DNA molecule. The physics and chemistry is not determining the information-bearing properties. Okay? So where did the information come from in this admittedly quasi-intelligently designed message? Obviously from a mind, okay? And that's where things get interesting. In our experience, and intuitively, there's a connection between mind and information. I'm generating information right now, maybe not as eloquently as I would have wished, but we are aware in our experience all the time of the way in which minds generate information. And so when I set off to grad school, having been exposed to some of the early founders of the intelligent design research community, I was curious about this issue. Could the design hypothesis be formulated as a rigorous scientific argument, an argument with explanatory power, predictive implications? And I became convinced that it could. And one of the reasons for that is I was studying the works of Charles Darwin. For Darwin had pioneered a method of investigating events in the remote past. And his method was known as inference to the best explanation. And that begged a deeper question, which is, what does it mean for an explanation to be best? But the historical scientists in the 19th century had worked this out in very practical terms. A best explanation was one that posits a cause which is known from our experience, our uniform and repeated experience, to have the power to produce the effect in question. Now, as I began to think about information as the effect in question, I started to think about it in relation to Darwin's method. And one day I came across a passage in one of the in a scientist who was a founder in the application of information theory to molecular biology. His name was Henry Quosler, and Quosler said this. He says, the creation of new information is habitually, uniformly and repeatedly associated with conscious activity. And for me, a nickel dropped, because I realized that the case for intelligent design is not just based on the fact that various evolutionary theories are failing to explain the origin of information, whether at the prebiotic level or the postbiotic level. The case for intelligent design is also based on our uniform and repeated experience of what it takes to generate information. Thank you. Whenever we see information and we trace it back to its source, whether it's in a hieroglyphic inscription or a paragraph in a book or a section of code in the computer code, we know that the information always comes from an intelligent source. And so the discovery that at the foundation of life we have information in digital form provides powerful positive evidence for the activity of a designing mind in the history of life. Now, one more quick point on this. This has also been oddly confirmed by work in evolutionary theory itself. There's a kind of experiment called a ribozyme engineering experiment, which is attempting to demonstrate the plausibility of one of the origin of life theories called RNA world. And the idea there is maybe instead of a cell self-replicating, maybe the first thing that copied itself and got natural selection going was a kind of a molecule. But it turns out, first of all, to get RNA molecules to copy even a part of themselves, they have to be, the characters in the RNA molecule, which are very similar to DNA characters, have to be very specifically arranged in order to convey information. And secondly, however, who's doing the arranging? And the answer is the ribozyme engineer. The engineer himself is responsible for the information, illustrating again that information always comes from a mind, from an intelligent source. Thank you very much, and thanks for your patience.
Tess, do you want someone to take you off for 20 minutes to get your...
I might just go in the dark.
Yeah. Thank you so much, Dr. Meyer. We're going to give him a little break now if Dr. Meyer would like to get away from these lights for the next 20 minutes. I'd like to move on to our next speaker. And a reminder to those of you here in the hall, and if you're watching us online as well, just to send in questions. My phone has been filling up. That's why I keep looking at my phone, if you're wondering. But there's still lots of opportunity. You would email scienceversusgodtoronto@gmail.com. On Twitter, it's #ScienceVersusGod. And if you're here in the hall, you can use the text number also that you received when you came in. We now welcome Dr. Denis Lamoureux, Assistant Professor of Science and Religion at St. Joseph's College in the University of Alberta. Dr. Lamoureux holds 3 earned doctoral degrees: dentistry, theology, and biology. He lectures throughout Canada and the United States in both Christian and secular academic institutions. Dr. Lamoureux is dedicated to teaching and research on the relationship between scientific discovery and Christian faith in a field known as evolutionary creation. He is a member of the Executive Council of the Canadian Scientific and Christian Affiliation, a Fellow of the American Scientific Affiliation, and is cited in the Who's Who of Theology and Science. Welcome, Dr. Lamoureux.
Well, thank you very much. I'm delighted to be here. I'm going to approach this question of what's behind it all from my academic discipline of science and religion. And there's one central issue, central problem we find within this discipline. We talk about God and science. It's this, that most people are trapped in a dichotomy. You're one of 2 positions. You're either on the, notice the choke marks, science side, evolution side, and of course no place for God, or you're on the creation side, the religious side, and of course this is God's side. But could there be some middle ground positions? Take, for example, an individual like myself. I'm a thoroughly committed and unapologetic evangelical theologian trained to the PhD level. I believe that the Bible is the inspired word of God. Lawrence, don't shake, okay? I've experienced miracles. In fact, I have a Pentecostal twist to my theology, and when I was here in grad school, I used to go to the Stone Pentecostal Church. And I believe in intelligent design, understood in the traditional sense of Psalm 19, the heavens declare the glory of God. So clearly that makes me a creationist. And at the same time, I am a thoroughly committed and unapologetic evolutionary biologist, also trained to the PhD level, and some of the best evolutionary evidence there is, the evolution of teeth and jaws. Like 97% of scientists today, I find the evidence for biological evolution is simply overwhelming. There is no debate whatsoever on that. When it comes to evolution, it is yet to be falsified, and it is the easiest theory to falsify. Find me one tooth down in the Cambrian, and we'll turn all of science upside down, but I wouldn't hold my breath waiting for that to happen. And as many have said before me, the explanatory power of evolutionary theory is amazing. Biology only makes sense in the light of evolution. So that clearly makes me an evolutionist. Now, many of my critics will say to me, well, that's rather illogical. Well, let me point to an individual who thinks I am perfectly reasonable. Charles Darwin, late in life in 1879, he dies in 82, says the following: "It seems to me absurd to doubt that a man or a woman may be an ardent theist, like a born-again Christian as I am, and also an evolutionist." Well, let me give you an example of why I think evolution is a magnificent theory from my discipline of the evolution of teeth. For nearly 150 years, we've been looking for the origin of teeth. We knew there was some sort of connection simply because you look at jawless fish, you see a fish scale very similar to a tooth like a shark's tooth. We see a similarity of a bony base. We find a pulp inside with nerves and blood vessels. And there is dentin. Dentin, that part of your tooth, and when you wear away the enamel, you get sensitive. I mean, this is a very old tissue. And over this period of time, we've been looking for transitional forms. Where are the transitional forms? And we haven't found them for the longest time. Now, there's a solution to this that many of my religious colleagues might suggest, and of course, it's bring in the hand of God and say God created the tooth. Well, of course, we've got a technical term for this. This is known as the God of the gaps, in that God intervenes in nature in different gaps. But we found over time, is this really a gap where God intervenes, or could it be possibly a gap in knowledge? And enter a spectacular set of fish called acanthodians. This past summer, I was an examiner on a PhD thesis of a newly doctored Dr. Stephanie Blay, and she worked on acanthodians. Now, where acanthodians show up about 425 to 400 million years ago, we go from jawless fish to jawed fish, and it's there where teeth first appear. Let me show you what she discovered. It's absolutely spectacular. Here's one acanthodian. There's the orbit for the eye. You can see where the scales are. This is the mouth. There's no teeth in this acanthodian. And what I'm going to do is enlarge this area of the upper lip. And I think you're going to see where I'm going with this. Notice the cheek scales. As they get closer to the mouth, we end up having little cones with little blades. Can you appreciate how this tooth would have a select advantage in terms of grabbing things? Now, to go from these scales, and it's a perfect example of a transition going on in a very gradualistic sort of way. From a morphological perspective, this is not very difficult to do. Just change a regulatory gene. Now, keep this in mind. Cones with blades. Let's look at another acanthodium. Can you see what we have here? Look at this, the first teeth, where you have cones with blades, and you'll notice there's a bony base here, typical of the very early teeth. And what is really fascinating, we're looking from the inside of the mouth. What we have here are indeed scales. So in other words, it was a jaw, the scales came into the mouth, and you see them from the inside, and on the top of the jaw, teeth emerged. And again, very easy to do just by changing some regulatory genes. Let's go on to one more acanthodium, which is wonderfully spectacular in terms of transitions. You can see the upper jaw denuded from scales, the lower jaw with some scales, and I'm going to enlarge this place right here. And you can probably see it right now. This is an unbelievable example of scales on the outside of the mouth, and as you get inside the mouth, you'll notice what you see. You have teeth. So when it comes to these missing fossils, sometimes we have to wait 150 years. Classic example of a transition. Which leads to probably my most important slide this evening, is to suggest to you as you go home, I hope before you go to bed, that you floss your scales. All right, this is the problem. Let me suggest a solution. Terms are very, very important. The terms teleology and dysteleology, I think we really need to grasp this. Teleology, it's a belief there's some sort of plan or purpose. Comes from the Greek term telos. I'm a teleologist. I root my teleology in the God of the Bible. Dysteleology, think of Richard Dawkins, in which there is no plan or purpose. The word evolution, it's a magnificent scientific theory that outlines how natural processes from which all of life emerge. Watch my finger here. Period, only deals with the physical. Now, whether there's a God or not, that's another discussion. That's not a scientific discussion. And when it comes to the term creation, it is simply the belief in a creator and all the stuff around us as a result of that creator. All right, let's look at some relationships here. Our culture has been thoroughly socially conditioned into believing that evolution is necessarily dysteleological. Churches do that, so does public education. But let's think outside the box. Is it possible that evolution is teleological? Could it be some sort of planned process with a God behind that? Now, if you're religious and wrestling with that a little bit, there's a magnificent analogy called the embryology evolution analogy. And it goes like this. I have yet to meet a religious person who thinks that when they were being created in their mother's womb, God came out of heaven, attached an arm or attached a leg. No, most religious individuals, Christians in particular, will use Psalm 139 and say, God knit us together, fearfully and wonderfully made. Well, why can't there be another set of natural processes that evolutionists call evolutionary processes, and that God used these to create all the world? And if you want to know where that argument comes from, yes, from The Origin of Species, Darwin's most important book, and his second most important book, The Descent of Man. Let's see what The Descent of Man has to say. Darwin says, the birth of both the species through evolution and the individual in the womb are the equal parts of the grand sequence of events, which our minds refuse to accept as the result of blind chance. Clearly, Darwin is not a dysteleologist. So returning to our paradigm, it's possible to be someone who believes that God uses evolution to create. That would make them a creationist. An evolutionist, also a creationist. And the term I like to use is the term evolutionary creation. Definition, it's a belief. No, it's not a scientific fact. It's a belief that God created the universe and life through an ordained, not a mistake, sustained, I am not a deist, God upholds the entire evolutionary process, and design reflecting evolutionary process. So returning to our title, what's behind it all? I think we have to introduce the term metaphysics. Meta, the Greek preposition behind, beyond, and physis, from which we get the word physics and physical. In my discipline of science and religion, there's a very important relationship of relating science and metaphysics. And here's a paradigm that most of us in the business embrace. Suggests that there is a reciprocal relationship between our metaphysics, or in other words, our religion, our philosophical ideas, our ultimate beliefs, and our science. Now, whether you get through between the two different paradigms, whether it comes quickly through intuition or use a slower process of reason, there is no mathematical formula to go from one to the other. Everyone needs to take a step of faith, and if you don't like the term faith, then say it's an intellectual jump or an intellectual leap. That's the way it is. Let me give you some examples. When it comes to metaphysics, the belief in realism actually informs our science. Most scientists are realists. But here's a question. How do you know you're not trapped in the matrix, some sort of computer program? You don't. You might be. I don't believe that's the case. Intuitively, it doesn't fit there for me, but nevertheless, it is a belief. So too, think about someone embracing the belief in dysteleology, no plan and purpose. Do you think that might affect the observational skills of individuals like that looking at nature? Or take, for example, individuals who have a belief in anti-evolutionism. Do you think that when they look at nature and they have this belief in anti-evolutionism, they may have evolutionary evidence right in front of their eyes and they'll overlook it? Okay, it's a little easier to go from the bottom to top. And we all do this. We look at our science and we ask the larger questions, what do we make of it? Now, this is the perfect opportunity to define the term intelligent design and to define it in the traditional sense. It's a belief. No, it's not a scientific theory. That beauty, do you ever notice all this design stuff is complexity, complexity, complexity? What about God the artist? So the belief, the beauty, complexity, and functionality in nature point to an intelligent designer. Using theological categories, this is known as natural revelation, whereby God reveals through nature. And a very key term, it is a non-verbal revelation. The term verbum in Latin means words. So in other words, it doesn't use words. It's like music. We all know that a symphony can communicate. So too nature. Nature is like this cosmic melody when we look at it. Let me give you some standard numbers, and these are shamefully simplistic. Take the standard cell, like a fibroblast, about 20 microns, about 1/1000 of an inch. Put it in the tip of the pin, you can't see it. In that single cell, stretch out the DNA, you got about 2 yards of DNA with a storage space about 200 telephone books. And then let's add that elegant component to it, the aesthetic component, and this comes from Richard Dawkins in his book, The Blind Watchmaker, when he talks about the cell having complex elegance, efficiency. Okay, that's our experience in science. Now Dawkins will take a step of faith and say, well, intelligent design is an illusion. But remember, that's Dawkins's belief. I make no bones about it, I take a step of faith. I look at the cell in biology and it just takes my breath away. It strikes me as there's some sort of mind behind this. And of course, you'll know where I'm going to go here. Charles Darwin wrote his autobiography in 1876. In his autobiography, he declares he's an agnostic. And so what he does is he gives an argument for God, takes it away, and gives an argument against God, takes it away. Let's look what he has to say about design. He writes, another source of conviction in the existence of God, connected with the reason and not with the feelings, impresses me as having much more weight. This follows from the extreme difficulty, and then he corrects himself, or rather impossibility of conceiving this immense and wondrous universe, including men and women, with their capacity of looking backwards and far into futurity as a result of blind chance or necessity. Clearly, again, Darwin is not a dysteleologist. Continuing, when thus reflecting, and commentators have been all over it when it comes to the present tense here, he says, I feel, this is late in life, I feel compelled to look to a first cause, having an intelligent mind in some degree analogous to that of men and women, and here's your present tense again, and I deserve to be called a theist, one who believes in a personal God. Now make it very clear, Darwin was not a Christian. He rejected Christianity in the late 1830s. But did he believe in a personal God? He's saying it right there. Immediately after this sentence, he says the following, this conclusion, belief in a personal God and intelligent design, was strong in my mind about the time, as far as I can remember, when I wrote The Origin of Species. And it is since that time that it has very gradually, with many fluctuations, become weaker. Now remember, there's a counter-argument, and here's a counter-argument. But then arises the horrid doubt. Darwin's doubt is not about the Cambrian fossils. Here is Darwin's doubt. Can the mind of men and women, which has, as I fully believe, been developed from a mind as low as that possessed by the lowest animals, be trusted when it draws such grand conclusions? And I'm sure you've picked up the problem here. What did he just trust to make this statement? It's contradictory. And the problem with this, it's self-referential incoherence. So from my perspective, I don't think Darwin responds to his design argument. I think it still stands. And continuing on the topic of design, in his last year of his life, he has a conversation with the Duke of Argyll, and the Duke of Argyll recalls, I said to Dr. Darwin, with reference to some of his own remarkable works on the fertilization of orchids and upon earthworms, a couple books that he had written, and various other observations he made of the wonderful contrivances for certain purposes in nature. I said it was impossible to look at these without seeing that they were the effect and expression of mine. I shall never forget Mr. Darwin's answer. He looked at me very hard and said, well, that often comes over me with overwhelming force. But at other times, and he shook his head vaguely, adding, it seems to go away. So here's my point on intelligent design. No, it's not about interventions. Intelligent design is nature impacting us. Intelligent design is a calling out from nature. I think from my perspective, a calling out from nature, answering who's behind it all, a creator. Well, there's a second problem when it comes to these issues of science and God, and I have to point in the direction of my own community, the evangelical community, and biblical interpretation. This is a term not many people are aware of, but most people are what are called concordists. Concordism is the assumption many religious people make, and I might add people who are skeptics of religion, or skeptics of the Bible, assume the Bible's supposed to do the following, that the Bible aligns with the facts of modern science. It's also another way of looking at it. It's the assumption that God reveals scientific facts in the Bible thousands of years before their discovery by modern science. Question: is concordism a reasonable assumption? Fair enough. I think it is. God created the world. I believe that. God inspired the Bible. I believe that. But the better question is concordism, this idea that there are scientific facts in the Scripture, a feature of the Bible? And my answer is no, because I believe the Bible has an ancient understanding of nature, in particular an ancient science, and you don't have to go very far into the Bible to see some of this ancient science. Just go to the second day of creation, and it states that God created a firmament to separate the waters above from waters below. And the term firmament, hard structure, is the best translation of the Hebrew word brachia and the Greek term stereoma. And you're all of a sudden saying, what is this? Stop for a second. When we read an ancient text, and this is not special pleading to the Bible, anytime you read an ancient text, you've got to respect its intellectual milieu. Put yourself in the ancient world. Suspend your wonderful 21st century scientific categories. You look up, what do you see? It's blue. It spits at you. Not such a bad idea. Fourth day of creation. God places the sun, moon, and stars in the firmament. Isn't that what it looks like from an ancient phenomenological, coming from the Greek term phenomai, to appear from an ancient phenomenological perspective? Absolutely. In fact, this was the science of the day. Here's a depiction of the three-tier universe from the New Kingdom in Egypt. And what you see there is your firmament in red with all the stars, and look what's above it. There's water. And we know it's water because the sun god, Re, is in a boat. And sun god crosses across the heavens, enters the underworld, and rises up again in the east. And while we're talking about Genesis 1, we have to talk about ancient poetry. And to define the term poetry, it just means structured language. And what we see is a pair of parallel panels. The Bible begins, in the beginning God created the heavens and the earth. Now the earth was formless and empty. And the way the creation is outlined in this chapter is the first 3 days are solving the formlessness, and the next 3 days are solving the emptiness. So day 1, separation of light from darkness. Day 2, you now know what a firmament is, separation of waters above from waters below. Day 3, separation of water from dry land. Now, on day 4, and this is why there's going to be parallels, you'll see that you got the sun, moon, and stars lining up with light on day 4. Now, this answers the question we hear repeatedly, why trust the Bible? You've got the light on day 1, sun on day 4. Do you not think that ancient people would have been aware of that? This is a classic example of poetic license. We do it, they did it. Now, when it comes to day 5, flying creatures and sea creatures for the biologists in the audience, what is the taxonomical connection between birds and sea creatures? Good, that's the answer. There isn't any. You've got a literary one. Empty space for birds, sea creatures, waters below, and of course dry land. I've got one question, and I think you know what the answer is. Is this science? Or is it something else? Well, let's have a few people answer that, prominent Christians. Galileo, way back in the 17th century, said with regards to the scriptures, the intention of the Holy Spirit in the Bible is to teach us how one goes to heaven. It's about theological things and not how heaven goes. Pope John Paul II in our generation said the following: the Bible speaks of the origin of the universe not to provide a scientific treatise, but to state the correct relationships. And we're very sensitive to that term in our generation. Relationships of humanity with God, humanity with the universe. We need to take care of the planet. Continuing, sacred scripture simply declares that the world was created by God, and it expresses this truth in terms of the cosmology, or in other words, the science and use at the time of the writer. In other words, an ancient science. And this is the principle in theology, very well known, the principle of accommodation, whereby God comes down to the level of ancient peoples, uses their categories, and delivers spiritual truths. Not being a concordist, it allows Pope John Paul II to say the following in 1996: new knowledge leads to the recognition of theory of evolution as more than a hypothesis. That's Catholic speak to saying evolution's a fact. There is no debate over this. Well, what about the evangelical community? There it is, Billy Graham, often considered as the greatest of all evangelical preachers of the 20th century. The Bible is not a book of science, says Reverend Graham. The Bible is a book of redemption, and of course, I accept the creation story. I believe that God did create the universe. Continuing, I believe God created humanity. Now, for those who are evangelicals, fasten your seatbelts. Whether it came by an evolutionary process and at a certain point took this person or being and made him a living soul or not, does not change the fact that God did create humanity. Whether God did it instantaneously or through an evolutionary process, God is still behind that. Whichever way God did it makes no difference as to what men and women are and their relationship to God. And Graham, throughout his career, has preached that humans are created in the image of God and that God loves humans immeasurably. Well, let me bring this to some conclusions. Number one, to answer the question of this session, I believe, and notice the word, I'm not going to talk about scientific facts. No, this is belief, and everyone has beliefs, including atheists. I believe that God is behind it all. I believe that nature reflects intelligent design. Again, no, it's not a scientific theory. It is a belief. Now, the one thing I hope you'll go out and dig up the Darwin literature is this notion. Darwin was not a Darwinist. And of course, this term Darwinism refers to a dysteleological approach to evolution. Darwin never was a dysteleologist. I hate to say it, but I will say it. I think the Darwin of Richard Dawkins is a Darwin created in the image of Richard Dawkins. Oh. And yes, I'm an evangelical Christian. Yes, I'm an evangelical theologian. And yes, I love the Word of God. In my morning devotion, I was in Luke 11 this morning. But the Bible is not a book of science, and here's the interesting thing. If you study within the text, you'll see there's an ancient science, and if there's an ancient science, don't use it to try to make out scientific theories today. How about a couple suggestions? Firstly, recognize that there are reciprocal steps of faith, call them intellectual leaps if you wish, between science and metaphysics, and it's not just religious people who do those. So too, skeptics of religion. We are all believers of some sort. Next, consider moving beyond this notorious and terrible evolution versus creation dichotomy, because simply stated, it's a false dichotomy. There are many middle ground positions in between. And finally, consider what is known as the two books model. And there's no better example of this at the beginning of the 17th century than from Francis Bacon, one of the founding fathers of the scientific method. And he says the following: let no man or woman think that anyone can search too far or be too well studied in the book of God's words, that is the scriptures, religious texts, or in the book of God's works, that is the marvelous book of nature. And Bacon concludes, but rather let men and women endeavor an endless progress or proficiency in both, and that's my hope and prayer for all of us. Thank you for your attention.
Thank you. Thank you, Dr. Lamoureux. Oh, great, thank you. We're welcoming Dr. Meyer back on the stage with us. Thank you. We're glad you're able to join us again. You're stepping right back into the fire because we're about to begin our time of 5-minute uninterrupted response. So I'll remind our guests not to interrupt each other during this time. And then immediately after, we're going to move into our what we're calling the coffee house style dialogue. So that will be a chance to interact more directly with each other. We do have you scheduled, Dr. Meyer, to offer your 5-minute response first. Does that still work for you? Okay, please go ahead. And we do have the timer, and I am going to be strict on this time, so I will interrupt you.
Just a couple points that kind of build on the talk. First of all, it's often said that the case for intelligent design is an argument from ignorance or a God of the gaps argument. And instead, the form of the argument that I'm presenting is actually what's called an inference to the best explanation. Again, building on the work of Charles Darwin and his method of multiple competing hypotheses or inference to the best explanation. And so the argument that I'm making is not an argument from ignorance. It's not a strictly negative argument about what evolutionary processes are incapable of doing, but rather it's based on our uniform and repeated experience of what intelligent agents are capable of doing. In other words, a cause which is known to produce the effect in question. So it's not an argument based on what we don't know, but also an argument about what we do know about the cause and effect structure of the world. That's one thing. Secondly, LaWReNcE said that it's an important principle of science to not allow a priori presuppositions to determine the conclusion of an idea or scientific idea, and I completely agree. One of the problems that we face in making the case for intelligent design is an a priori assumption that says we have to limit scientists to strictly materialistic explanations regardless of the evidence. There's actually a principle that's used by many historical sciences or science generally, which has a name. It's called methodological naturalism, and it says if you're going to be a scientist, you've got to limit yourself to explanations involving purely materialistic causes. But the problem with that is that there are certain kinds of effects that we know from experience are not the result of undirected, unguided material processes. If you walk into the British Museum and you see the inscription with all of the, again, I'm sorry, pulling, you know, what the archaeologists look for in, sorry, one thing with migraines is it's hard to pull names, but anyway, if you find an information-rich signature in an archaeological inscription, you don't try to explain it by reference to wind and erosion. You know that there's another kind of explanation that's involved in explaining how that information-rich signature came from. So if you have a rule of method that says, a priori, we're not going to consider intelligence as an explanation for certain kinds of effects, you're going to miss what the evidence is actually pointing to. So I agree with Professor KrAUSs that we want to follow the evidence where it leads. We do not want to defend or depend on a priori assumptions to govern what the right answer is in respect to the origin of information and the origin of life. And then finally, I think the fine-tuning argument is really interesting as well. It also illustrates the same principle that I was talking about, where the attempt repeatedly, and we find this in evolutionary theory, that the explanations that are posited are either just begging the origin of information presupposes either prior information, or it requires some unexplained source of information that's coming from another source. So the RNA world explanations require information input from the investigator. And a similar thing happens with the fine-tuning argument, that the proposals for explaining the origin of the fine-tuning is no, I think I better stop. I've made my 2 points, and I'm just struggling. Yeah, I'm sorry.
Dr. Lamoureux, it's now. Thank you. I can't imagine how hard that is. Dr. Lamoureux, it's your 5-minute response time.
Can I get the slides back up, please?
Can we have Dr. Lamoureux's slides up? Do you have that available? Okay, it's coming.
Okay.
That's mine, but he can talk about it.
Sorry, folks, we'll get that straightened away.
I'm number one. Right here. Here we go.
Thank you.
Thanks. This is going to be tough for me. I mean, I really feel bad for Steve, and I came prepared, and I'm going to wrestle with this. Steve's a friend. Steve's a brother in Christ. I've prayed with Steve. What you're seeing here are Christians disagree, and there's a side that I just don't want to do this, but I have to do it. The clarity when it comes to the issue of what's this design theory just wasn't clear. And so what I'm going to do is basically Steve's claim to fame. He is the issue of the Cambrian explosion. He talks about acts of mind, not talking about natural processes. Is this a God of the gaps? I think it is. And in fact, it's being aggravated by a gap in knowledge. And so what Steve will claim is in this period of the Cambrian explosion, he likes to make it tight to about 530 to 525 million years ago. It's a much longer period. And of course, when you hear a term like the Cambrian explosion, what are religious people going to think? Aha, the hand of God comes in there. Now, when Steve met me back in '94, I was exactly where Steve is today. We were both anti-evolutionists, assuming there's some sort of interventions along the way. And what I'm going to do here is just show an example of this methodology. And the reason I'm so familiar with it, I used to do it. When I started my PhD in evolutionary biology, I mean, I was trying to put together an anti-evolutionary theory. And this comes from Steve's book, Darwin's Doubt. And let me give you credit to Steve. Steve has read a ton of scientific literature. And he uses Graham Budd and Soren Jensen, and he uses a quote from them, state that the known Precambrian Cambrian fossil record has not been misunderstood, and that there are no convincing bilaterians. Now, these are creatures with a left and a right side, candidates known to the fossil record until just before the beginning of the Cambrian, 543 million years ago, even though there are plentiful sediments older than this that should reveal them. Okay, so no bilaterians, and of course the implication is an act of God, an act of mind. Showcase a little bit more of the work over at the University of Alberta from our geologists. Here is what we call a bilobate furrow. It's a track of a bilaterian. You'll see there's two sides to it. There's a mussel basket at the bottom, and it's going across a sediment. It's a very small creature, about 5 millimeters to 2 millimeters. And remember, when it comes Steve using Budd and Jensen, saying we're not going to find any of the, or we haven't got any evidence of such bilaterians. And well, we actually have an intrusion going through this sediment, and look at the date. Do you notice we've increased it now 40 million years? And to have a small creature like that living for over 40 million years, it gives you a lot of opportunity for life to evolve. Now, one of the things to note about it is where are these creatures in the Ediacaran? There's not much oxygen. They are in microbial mats. And as a result, these creatures have to stay in this little area, and through a variety of different duplications, we have all the potential ready to explode when it comes to the Cambrian explosion. Now, when it comes to Dr. KrAUSs, I mean, I absolutely love this book, and I'd certainly encourage people to read it. LaWReNcE KrAUSs is not only a world-class scientist. I mean, these physicists are amazing in terms of their skill set in mathematics, so I'm not going to challenge him at all on that. One of the things about this book that I find so fabulous is he takes these complex mathematical ideas and draws cartoons for a biologist like me to understand them. And he does a marvelous job. The one thing I would suggest is he just doesn't do science here. There is some metaphysics going on. So that's where I would suggest we can challenge the metaphysics. However, when it comes to this title, A Universe from Nothing, is it really nothing? And so I'm going to appeal, and this has been noted from a variety of physicists, that the nothing really is not nothing. And of course, when you see a title like that, you get the impression it is out of nothing. And here's David Albert, atheist by the way, double PhD, says the following: KrAUSs seems to be thinking that these vacuum states amount to the relativistic quantum field theoretical version of there not being any physical stuff at all. But that's not right. Relativistic quantum field theoretical vacuum states no less than giraffes, refrigerators.
That's time. That's time, Dr. Lamoureux.
How about if I just end with one quick sentence? Yep. The point being is the descriptive science is good. It's just the steps of metaphysics that can be challenged. Thank you.
Thank you very much. Over to you, Dr. KrAUSs.
Yeah. Okay. David is a professor of philosophy, not of physics. But anyway, it's hard to know where to begin. And again, I feel for Stephen, I've been known to bring on migraines in many people. And I apologize if I was, well, anyway. But the part of the thing that flabbergasted me was before you got ill, which I was amazed to read about. Something that I think would fail high school biology. Evolution is not a random process. I mean, and Richard talks about it at length, and so should we all. Evolution is a directed process. It's directed by natural selection. It's the argument you gave is the same as the argument that the old argument, well, it's, you know, creating a living being by evolution is like a hurricane going through a junkyard and producing a 747. That sounds pretty convincing if you talk about all the possibilities for all the parts of the junkyard, but that's not how it works. It's directed. I was trying to think of an exact analogy, for a reasonable analogy, and it is the following. It's an interesting thing. So again, I'm trying to give some facts that are relevant aside from this argument. How long does it take light to get from the center of the sun to the outside? Okay, I'm not going to ask you, but I'll tell you because it's an amazing thing. It's 1 million years. It's 1 million years because light does a random walk from the center of the sun to the outside. By the way, it's one of the things I use when I talk to young Earth creationists. I point out if it was 6,000 years old, the sun wouldn't be shining. But in any case, the point is, if, however, there was natural selection, and every time a random walk directed a photon inward, and in fact that trajectory was removed, it would take about 6 minutes to get to the outside of the sun. So the point of this randomness, where you look at all possible arguments, is the biggest fallacy that has been used for centuries to try and distort what evolution is all about. And in fact, the best example I can think of, even more recently, involving digital algorithms, which you tried to talk about, is the machine that just won a Go. Okay, it used evolutionary learning algorithms. It could have, I mean, if you looked at all the algorithms it could do by random, in the history of the universe, it would never be able to win at Go. It wasn't directed or the algorithms weren't even written by the computer scientists. The machine itself learned by trying different things and seeing what worked and didn't work, and threw out those directions that didn't work. In a short time, in fact, the lifetime of deep thought, that machine, which has only been around for a few years, it was able to beat the best Go player in the world by evolutionary algorithms. So randomness has nothing to do with evolution. I was just shocked to hear that misguidance put in. In fact, regarding this idea of DNA, I mean, again, it's amazed me. No one suggests that DNA is the first form of life. And in fact, it seems to me you have two arguments. You go, gee, it really seems strange. I don't understand it. Or actually, you try and understand it. And the institute I run, the Origins Project, for example, ran a meeting on the origin of life. And one of the most important things is no one thinks DNA was the first example of information processing or life. In fact, there's probably an RNA world. One of the things that was really interesting to discover is in early life environments, which are appropriate for extremophiles on Earth, in fact, what's called enthalpy, which is a property of chemistry and physics, drives systems to form complex molecules. Moreover, there seems to be natural trajectories by which RNA, which is the precursor to DNA, could be naturally formed even in protective and cometary systems. We don't know the answer to do it yet, but instead of just saying, it just seems impossible, we're doing it, which is what science is all about. Let me, if we do have time to go to when you get to my slides up, I'll go to what I was going to show. But let me just talk about Denis. The thing I can't understand is poetic. You always say, well, the Bible is really garbage when it comes to science, but that's okay because God was a poet, not a scientist. And there's pretty good poetry in the Bible. I'll give it that, at least in Psalms. But the argument that somehow, Darwin didn't use poetic license when he tried to explain how the world worked. Now, you might say, Bible isn't about how the world worked. It's about how the world should work. I certainly hope not. To get to heaven, what you do is you rape women and kill children who aren't Jewish. The Bible is the most immoral document I've ever seen in my life. And why you would think it's the Word of God as opposed to say, actually, I have the flying spaghetti monster on my level here, which I think is a much more rational argument for how the world came about and a much more moral one. But why you believe that's the Word of God and not the Egyptian or the Norse myths or anything else is beyond me. Let me just close by saying, evidence for design, lots of things look like they have evidence for design. Those aren't Christmas ornaments, they're snowflakes. This is a beautiful Buckminster Fuller designed geodesic dome. That's Buckminster Fullerene, which comes in soot. Nature produces what looks like to be exquisite design without the hand of anything but physics and chemistry. Thank you very much.
Thank you, Dr. KrAUSs. Thank you, everyone. Now we enter into our time of open dialogue between our three guests. We're actually going to go for 15 minutes on the clock, and please interact with each other, and I will be here for you. Yes, no. Dr. Meyer.
I'm not sure how well I'm going to be able to contribute here, but let me just say a couple things to make sure that my position is being accurately represented.
Fair enough.
It's kind of, one of the things that happens to me, it goes through a little phase, and then just pulling words. It's like you don't have a memory, but there's a big difference between a purely chance hypothesis and a hypothesis that combines chance and natural selection. And the critique that I'm providing is one which is critiquing natural selection acting on random mutational variations. So I'm not arguing from chance alone. The point is that so I am perfectly aware that the mechanism that I'm critiquing is not straight chance, but it's a search for possibilities, and then natural selection would select those that are functionally advantageous. And so I don't have a simplistic understanding. And in fact, in my work on origin of life, I look at chance hypotheses, those that combine chance and necessity, including the RNA world hypothesis, and also those models that involve self-organization, and that really is comprehensive as far as the different models that have been proposed. The algorithms that Professor KrAUSs mentioned are very interesting simulations, but they invariably involve information being input by the programmer. Dawkins has this famous algorithm where he says he has the program simulate a Shakespeare phrase, methinks it's like a weasel. Mm-hmm. But it doesn't simulate the way things actually work in biology, where in biology, in the algorithm, he's positing a process. Anyway, the programmer inputs information in the algorithm. I'm really sorry, folks.
No.
Steve, let me, okay, I don't want to hit too much because I know you're having a hard time, but I accept that maybe I can't believe that you don't recognize that what you appeared to say was completely wrong. But, because I think you have a deeper understanding than what appeared to be on stage. But the examples you gave were very misleading. The example you gave was of a lock picker with 10 to the 10th combinations, doing them randomly. That's not work. If after each one there was evidence that things were moving in a certain direction, and those directions which didn't work, he would ignore them. In fact, that's how many lock pickers work. They actually do. Richard Feynman could pick locks at Los Alamos for a reason. So the point is that example which you gave was very disingenuous.
No,
and
it isn't. It isn't, because the functional outcome is what would be selected by natural selection. But you have what drives the search is the mutational processes.
But it's not random at all stages. There's a change, and you check to see if that change goes in the right direction.
No,
and if it doesn't, you move in the right direction. That's how it works.
No, natural selection selects for the functional advantage.
Yeah.
But the mutational search has to find that outside within the combinatorial sequence space that's being explored.
But the main thing is it doesn't have to search through 10 to the 10th combinations. That's the central point.
No, it's 10 to the 77th for a single functional protein fold. And if you get the right one, then natural selection can kick in. But natural selection doesn't work until you have something functional to be selected.
In fact,
No.
Well, this debate we can go on, and maybe it's not worth pushing it too far. But the point is that to make, I've been a scientist for a long time, and I've seen people say, I just can't understand how this could possibly happen. It seems impossible. And then we find a way. And what you're saying is that, look, I don't understand how this could happen naturally, okay? But every bit of evidence, an example I gave you, which was in fact not involving programmers, the reason I'm motivated by this is we just came from a meeting at my institute at the same time as we had the event with Johnny, which was on pattern processing in the human brain and in machines. These were neuroscientists and machine scientists trying to understand how intelligence arises in the brain and machines. And in fact, this whole process of how the machines that beat the Go learner were fascinating because they were evolutionary algorithms. They did not require, in fact, input from a programmer. It was a perfect example of natural selection. But let's
every evolutionary algorithm is the product of a programmer.
Let me jump into this. Yeah. I mean, this is when Steve's using locks and cars and numbers, those are engineers trying to understand biology, and that's not how biology works. The theory is common descent. It's not simply natural selection, it's also a question of variability. But it's natural selection via modification. And when it comes to new genes, we have a classic example of nylonase, which nylon is a synthetic molecule made by humans, and was made in the 1930s, and by the 1970s, bacteria had found a way to digest it. And how did it do it? It's by doing duplications of genes and searching that random. And in only 40 years, we have brand new genes. And from that first gene that emerged, then it was a duplication, allowing another gene to go ahead and search it. Now nylonase has a gene that is 200 times more powerful, and that's just in a matter of 40 years. So the idea that, it's impossible to make proteins, it's just not true. Now, Steve talks about information. This is the simplest thing in the world of biology. They're called duplications. It's happening all the time. And not only duplications of genes, it's also duplications of entire chromosomes. And this is how we have the Hawk series.
But that's not an origin of new information. That's like saying you put something in a photocopier, and then the copy gives you new information. No, a duplication event is replicating the same information you had before. We have a specific theory about the origin of information, which is that undirected mutational processes can produce minor changes of a pre-existing protein fold, but the space that has to be searched corresponding to a new protein fold is not feasible, is not plausible because of the space, the size of the space that has to be searched in relation to the probabilistic resources that are available. And so your examples are not actually a critique of the thesis that I'm putting forward.
Well, hold on, Steve, hold on. In 40 years, just 40 years, we got nyelinase. Just 40 years. So we don't have the 10 to the 77. All these statistics are not, this is not how evolution operates. And there's a real problem with anti-evolutionists of bringing in this engineering mentality. It does not work like that.
Well, your point is that these arguments are distortions of the way the world actually works. That you can look at any complex structure. You can look at that. You can look at that snowflake and argue that there's no possible way nature could produce such a complex system which stores information, or Buckminster Fullerene. The point is that
a snowflake isn't an information-rich structure. That's something that can be explained by self-organizational processes. And ideal with self-organizational thesis in signature in the cell.
If you argue as you just did, which you tried to do using Shannon's theorem, that in fact the information stored in a system is basically how far away it is from thermal equilibrium, I think you'll find there's an incredible amount of information stored in a snowflake. Shannon's theorem would tell you that. It's just a fact.
No,
it's not entropy.
It's explained
the point
by
is if you add energy to a system, you can build up incredibly complex organizational structures, as you said, self-organizing. You can't do it if you don't put in energy, but thankfully we have the sun. But let me go to let me go to the other thing you said.
Let me ask people. I'm really struggling to pull words, but I've written a 550-page book on this. I'm well aware of self-organizational theses. Snowflakes are not equivalent to digital code, and I have a chapter. I'd encourage people to read Signature in the Cell and Darwin's Doubt.
Well, here's the point.
Get a better sense of what my thesis is, because that's a misrepresentation.
And you have a thesis, and it hasn't gone anywhere. Okay, that's the point.
Disagree.
Now, hold on. Let me make the point. You said really what you're trying to do is science. Great. Okay? What you try and do when you do science is not just tell a story and you say, well, look, I can't really see the way this is going to go. So and I agree that maybe, materialism is an assumption. Perhaps you could say, let me assume that there's a hand of God, and I'll make that my scientific assumption. But then what I'll try and do is make predictions. And I'll try and make predictions that I can test. And if they work, you know what? Everyone jumps on the bandwagon. There's a reason that no one's jumped on your bandwagon, because because the whole thing doesn't make any prediction that has yet been validated by anything, and every time it does make a prediction, it's been wrong. So that's it. We don't, you're not. Okay.
Go ahead.
Well, there's a lot of predictions that the theory of intelligent design has made. At the end of Signature in the Cell, I list 10, one of which is that the DNA, which was said to be junk, is not junk. We understand that there are mutations that alter the sequences of genetic information, but we predicted that the DNA the non-coding regions of the DNA would be we predicted they would be functional, and we predicted that we would be looking at something that was the signal versus the noise. We expected that the signal would dwarf the noise, not the other way around. And what's called the ENCODE project has actually confirmed that prediction of intelligent design. I'm sorry, I'm so inarticulate.
But Steve, let's be fair about the ENCODE project. It wasn't the intelligent design theorists that put this forward. It was the scientific community. And the scientific community changes its views.
One of whom was Richard Sternberg, who was commended by University of Chicago cell biologist for being a cutting edge in this.
Steve, you can almost count these guys on one hand. You got Doug Axe, you got Sternberg. I mean, the people who put this together with the scientific community, and here's the beauty of the scientific community. I was raised with DNA's junk. I mean, but we've changed our views. And now we recognize that 80% of the so-called junk has some sort of functionality. And it didn't come out of Seattle and the Discovery Institute. It came out from the scientific community at universities like this.
Jim Shapiro at the University of Chicago, upon the publication of the ENCODE project, wrote an article commending Richard Sternberg for being on the cutting edge and making the prediction about the functionality of the non-coding regions of the DNA. Sternberg was a longtime doubter of the evolutionary theory and a private supporter of intelligent design. And his prediction was a consequence of intelligent design as a way of looking at the origin of information.
Be assured the scientific community
ID
did
has
not go.
predictive consequences.
Yeah.
I spell out 9 others in the epilogue to my book,
No,
and
but
there are many others.
The key point is falsifiable concepts. So, okay, so, you know, it's an old statement that if you sort of a monkey on a typewriter taking long enough will eventually type out Shakespeare. So the point is, there are lots of arguments, and in fact, evolutionary biologists would argue for arguments why junk DNA has a functional purpose. And there can be many functional purposes, including error correction. You can imagine a million reasons why it would have functional purposes. One might be that God did it. And the point that you have to do if you're a scientist is say, okay, that's my hypothesis. How can I try and disprove that hypothesis? Because that's what scientists really do. How can I do something which can show that you know, there's one of my favorite cartoons is a picture of a physicist drawing on a board, and he's got to the conclusion, and there's this thing in the middle that says, and then a miracle occurred. And his friend says, I think you should be a little more specific at that step. And the point is, it's okay, great, you know, but what can you do to try and falsify that assumption? And what new things what kind of predictions can you make about the nature of the junk of DNA and what functionality it has and all the rest? The point is that right now, so far, evolutionary biologists have not found any need for God. And I think that's the real point I want to make. This whole thing makes it sound like God is relevant.
No, they have not found a causal explanation for the origin of the information necessary to build protein folds.
Lack of understanding is
But there is an alternative explanation based on our knowledge of cause and effect.
Which God?
We know that.
Which God?
We don't attempt to answer that question.
Okay.
No, that's not a clap-worthy.
Who organized the God?
That's not clap-worthy.
No, where did the information of God
I haven't
come
answered
from?
his questions. Don't clap. That's just shouting down. We're positing a mind because of our knowledge of what minds
Who created
can do.
that mind? Where did it get organized?
What's that?
Was it causal?
It's
was it
based on our
accidental?
knowledge of cause and effect, which is what Darwin's method of scientific reasoning involves.
So ultimately you say it all comes from something you can't
Lawrence,
understand.
let him have his interventions. I am not philosophically opposed to the God of the gaps, but there is a prediction. No, hold on. No, you have to keep that as a possible. Look, you know very well I don't embrace it. But here's what would happen if there is indeed an intervention. And this is the history of it. The gaps have always closed.
Yeah. And you lose God.
That's right. Well, okay, that's right, and lose God.
That's the danger.
But if indeed there is a gap, it should get wider and wider and wider. In other words, there's no way we can get natural processes here. The more we understand natural process, it's definitely not to get it. But the history is the gaps have always closed.
They've always closed.
And then there's another piece of this puzzle.
The history of origin of life research.
Hold on, Steve. And there's another piece of this puzzle. And let's be straight up that when it comes to this intelligent design movement, this is my Christian tradition. These are evangelicals, the vast majority of them. And they take their Bibles, they go to Scripture, they see in these early chapters divine interventions from God, and these are carried over. They work with an assumption. I will tell you as an evangelical Christian, we have an 11th commandment in our tradition, and it's this: thou shalt not believe in biological evolution.
Yeah.
Thank you.
We're
going to end our time of dialogue there. Thank you, guys. And I want to just give a shout out to our people who are joining us by live stream. Thank you. We know we're going over time, so we're going to move into our time of questions, knowing that you can circle back around on some of this stuff. And
how long is this going to go, just so we know?
Yeah, we will. We were scheduled to end about 5 minutes ago, at 9:20, so I need some instruction from you, Steve. Okay, we're going to do 7 minutes of Q&A. This first question will come to what you were just speaking to, I think. Let me just find it. We've got a lot of questions coming in. Why would God, the supernatural, intelligent designer, use evolution to create humans when he has so many other options available? Why use the same method as naturalism? That's a question from one of our viewers or someone in the audience here.
I think evolution is absolutely a brilliant way by which God created, because what it gives us is an opportunity to make that step of faith, whether there's a God behind it or whether there's nothing behind it all. If it was a young earth creationist world, we would have a certain fossil pattern. At the very bottom of the fossil record, we should have all forms of life, humans walking with dinosaurs. But that is not what we find. And if it was that, with the young earth creationist model, there would be no element of faith involved. It would be a closed case that there is a divine creator, and it'd be the creator of the Bible and Genesis 1. So that's rooted in a concordist question that's being asked.
Well, if God, if God existed, he's a pretty lousy designer. She, forgive me. Because 99.999% of species that have ever existed are extinct. And I expect humans will join them at some point.
Yeah, but you know very well...
And it's a really interesting way of designing. For instance, what you do is you make dinosaurs, and then you say, let's kill them all. And then let's kill them all so we can make something that's going to make human. It's just such a ridiculous notion that there is this intelligent path to create, there's just no intelligence. So if he's a designer, we could do a hell of a lot better.
Dr. Meyer, did you want to?
Yeah, I'm just wondering if I could ask people who are interested in this to please maybe read Signature in the Cell or Darwin's Doubt, my books. I'm not really able to make as good a defense, but I would like to explain that what's going on in evolutionary theory today. People who are defending neo-Darwinism are pretty much no longer at the forefront of evolutionary biology.
I hate the term neo-Darwinism, just like I hate relativism.
Yeah, that's right. And there
it's an oxymoron. It doesn't mean anything.
Well, it is. It's the dominant textbook theory of evolutionary.
You mean Darwinism?
Steve,
or
may I finish, please? Okay.
It's pejorative.
And leading people in evolutionary biology are now themselves saying we need a new theory of evolution, because the mutation selection mechanism does not explain the origin of information. It doesn't explain the origin of epigenetic information. It doesn't explain molecular machines. And one of the things I discuss in Darwin's Doubt is the 6 or 7 new theories of evolution that are being proposed that are trying to address the origin of information. And invariably, these proposals invoke mechanisms that themselves just push the question back one generation and don't answer it. So this is actually a really big problem. And in origin of life studies, trying to explain the origin of the first life, the problem is even deeper. The chemical evolutionary theory has not explained the origin of life. And
we're coming very close.
We're coming to, no, we're not coming close at all.
In the meetings I run, people are very optimistic.
Best explanation is the RNA world. RNA world.
Let me ask you a question.
RNA world requires an experimenter to get an RNA molecule to copy itself. The best they've been able to do is get an RNA molecule that copies 10% of itself, and the experimenter puts the information in the molecule. So the information that's being simulated is coming from an intelligence.
Let me hit something you said. So everything pushes the question
which
back.
Which points to intelligent design.
In what sense is the difference? In what sense? So I think you just agreed earlier that the whole point of the God thing is to push all the questions back to someone. You just say, I stopped thinking, it's God. Okay, all the questions go back, the same problems, the same problems, same problems. Oh, we have God, so we don't have to worry about it. I mean, so the whole point of this God thing is to push all of these deep questions, which we're trying to resolve by actually thinking, and push it back to say, you know what, we just don't understand the nature of God. And we'll never understand it.
That's not the argument we're making.
Which God are you criticizing here?
Well,
the God of the gaps.
Which
is this
which
the God of the gaps?
Which God do you
is it the
deeply
God of the
believe
gaps?
in?
What?
Do you believe in the Norse God?
I don't believe in the God of the gaps. You seem to be.
Which
It's
of
a
the
caricature.
thousands
It's a
of
caricature of God that you're putting together.
And that's also not.
It's a
That's not what we're arguing for. We're arguing for a mind of some kind, based on our knowledge of cause and effect, which is something that is
Which
part
may-
of the observable world that we can
let me
we can
just
look
say-
at.
You have to be clearer on that when you say a mind. You're
Yeah, what
talking about
mind?
an intervening mind.
Dr. KrAUSs,
talking
here's
about
a
acts.
question from a viewer, which
Yeah.
I'd just like to be fair to the people who've been waiting. It seems to me that someone who argues that there is no reliable scientific means to detect design in nature must also accept that forensic science is not reliable by the same arguments. Would you say this is a fair argument comparison, and why or why not?
Whoa. I don't understand the question, I guess. I think that forensic science tries to determine unambiguous ways to determine the cause of certain effects. And it is either reliable or unreliable. In many cases, it's overstated. I mean, the legal system is full of examples from lie detectors onward that don't work. However, DNA testing does work, and it's helpfully saved many, many people from the obscene system of capital punishment that we have in my country. And so I think it's a clear example of the fact that the scientific method works. And I think that's the point I want to say. I was going to say it earlier. I've been a scientist for 35 years, and I've never once gone to a meeting where the word God came up, because it hasn't yet been necessary to invoke that in anything that we've ever done, and we've done pretty well. And so, yeah, anyway.
Okay.
Can I follow up on that?
Can I?
I mean, I'm fascinated by this CSI type stuff. But you want to know what CSI is? This is what we do in evolutionary biology. We take bits and pieces of evidence and then we try to reconstruct the past. So I'm not sure where the questioner's going, but I mean, that's what evolutionary biology is. It's
And we not
reconstruction.
only recreate the past, that's the other thing. They make it seem like evolution is a historical science. All science is historical science.
yes.
Because it recreates the past, but it makes predictions about the future. It makes predictions about the number of chromosomes in humans versus chimpanzees. It makes lots of predictions. Each one of could be falsifiable. It's not a story. It's a predictive story, and that's what makes it science.
Preach it, brother. Now,
Yeah.
Okay, and Dr. Meyer wanted to put a word in for that.
I actually agree that historical sciences have both historical scientific theories have explanatory power, and they also sometimes allow predictions. Intelligent design is an historical scientific theory. It follows the exact method that Darwin pioneered, and it also provides explanations for the origin of information, and it makes predictions as well, and those are outlined in the books.
I encourage
I
you
have
to
something
start.
to say, though,
That's
to
a
Lawrence, something about his
misrepresentation.
work.
Okay.
Thank you.
I was really looking forward, and I'm sorry I didn't really mean
okay.
to pull this thing.
Talk cosmology.
I was.
We'll
I'm
talk after.
really into LaWReNcE, and I'm really into what you're doing, and I wish we'd had more time to talk about it, and hope that we can have that conversation, because
Maybe over beer.
And let
Yeah.
me just say to Stephen, I really hope he keeps working, and one day I hope he does something that works.
Okay, I have a question from a participant who has been waiting.
sheep's thought.
This
you
is
know.
to all the speakers. This is going to be the last question, and then I'm going to get you to go in the order in which you're seated. So we'll
Okay.
start with Dr. Lamoureux and just do a wrap-up statement in 2 minutes or less. To all the speakers, do you think that it is possible to have other evidence for God besides scientific evidence? For example, historical evidence. Do you think that there is good historical evidence for the life, teaching, death, and resurrection of Jesus? What do you make of Jesus Christ?
I think we know the answer from two people at least.
answer yes. And Jesus Christ is my Lord and Savior. But that's a faith statement. I resonate deeply with Dr. KrAUSs. I mean, I've tasted the power of the scientific method, but that's one method. There are other methods: philosophical method, theological method, and we're in a postmodern culture. Personal experience. When it comes to scientists, we tend to think of them as not being religious, but you know, there was a famous study in '97, went to the U.S. Who's Who of Science, and found that 40% of them believe in a God who answers prayer that's more than subjective and psychological. In other words, quite tangible. So that, I think, is a very serious data set that has to be considered. It's not a proof for God, because in the end, it's a function of faith. I experience that spiritually, but in the end, it's ultimately faith.
Thank you. Dr. Meyer?
Let Lawrence go on. Well, we're talking about a faith question.
Yes,
Yeah.
yeah.
Jesus Christ and all that.
Well, yeah. I actually think that the science is really interesting overall. That the science looks to me exactly as it should look from a theistic point of view. The universe has a beginning. The universe is finely tuned from the beginning, and there is evidence of design that has, in the form of the infusion of information into the biosphere since the beginning. This is exactly what you'd expect from a theistic worldview, which is why I made the comment when I first started my talk that I wasn't here to argue God versus science, but rather to say that there's a very coherent theistic view of the main evidences that we have from about biological and cosmological origins. And I actually like some of the work that LaWReNcE is doing on quantum cosmology. There's a deeper underlying physical theoretical structure that lies behind the conclusion he's drawing, which I think actually points in a theistic direction, that there's a theistic way to interpret the work he's doing in quantum cosmology. And at some point, maybe we could discuss that further. Yeah.
Thank you very much, Dr. KrAUSs.
Well, look, I will say that, first of all, it's really important to point out, I didn't get a chance, the fine-tuning argument is a big misnomer. The constants of nature that are fine-tuned, actually, if they were tuned to more natural values, would make a better universe for life to live in. So there is fine-tuning, but it's not clearly fine-tuning that leads to life, and that we should really appreciate. But more importantly, I think the point that I tried to make, to throw out a bone of sorts, is that, and not theistic, but deistic, is that science, as I said before, cannot disprove that there's purpose or design to the universe. We can look for it, we can find no evidence, but the lack of evidence doesn't necessarily say there is no design or purpose. But to come back to the questioner's question, the relationship between that idea and some specific theology, which is clearly derivative based on earlier pagan theologies, the same sort of miracles occurred then and there, and the fact that there's no evidence from the time, everything that this Word of God that we're told about was written by people well after the fact, often contradictory, and so there's no evidence that would stand in a court of law, much less in a court of science, that any of the fantastical things that happened actually happened. They're much, as Richard Feynman used to say when he was talking about UFOs, he believes that they're much more likely to the known irrationality of humans than the unknown rationality of aliens. And I think we can say the same thing about religion. It's much more likely known due to the fact that teleology, the need to find an explanation, is hardwired in our evolutionary biology, because in the ancient savanna of Africa, if the leaves rustled and you said, okay, well, that's nothing, you probably didn't survive to pass on your genes. We like to find reasons for things, and as Fox Mulder said, we all want to believe, but when it comes to personal experience, Richard Feynman also said, the easiest person to fool is yourself. And if you're a scientist, you constantly have to wonder whether you're fooling yourself.
Thank you, Dr. KrAUSs. We're now going to wrap up. Thank you, everyone, for your patience and great stuff. So if you'd like to give a closing statement, please do, very brief. Well, it could have been.
Maybe.
But please, Dr. Lamoureux, go ahead.
Great, thanks.
Yeah, 2 minutes each. Thank you.
Well, I came here to thank you folks down here in Toronto for Connor McDavid. Edmonton loves you guys. My central concern in this discussion is, and I'm going to put on my pastoral hat, young people in my tradition are leaving the church in record numbers and at record speed, and the issue of evolution and science.
I'll applaud that.
The issue of science and evolution in particular is a disaster, and as we do the surveys on these students, we know that's a problem. I teach undergraduates, and I would say the average evangelical comes into my classes compartmentalized. Sunday morning is one thing, school is another thing, and they know there's got to be some sort of integration. All I really do is I call out to the pastors, the leaders of churches, we have to fix this situation. Evolution is not antithetical to an evangelical faith. Thank you.
Thank you very much, Dr. Lamoureux. Dr. Meyer? Dr. Meyer?
Go first.
Are you okay?
If you could go
ahead,
yeah.
Dr. KrAUSs.
Okay.
Thank
If you want to
you.
do that. Evolution is, there are religious scientists, and there are people who are religious, like Denis, who also do science, and I don't know exactly the science you, but you discussed some of it. And as a very famous biologist, Haldane, once said, when I'm going to the laboratory, I'm an atheist, because when I go in the laboratory, I don't think there's some being turning the dials and determining what's going to happen. So if I'm an atheist in the laboratory, it seems perfectly reasonable for me to be an atheist outside the laboratory. Once again, the God hypothesis is an unbelievably outlandish hypothesis, and that doesn't make it wrong, but that means that if you have it, you have to have you have to try and develop good reasons to have that hypothesis. And so the fact is that science has demonstrated through everything we see in nature that this particular God hypothesis doesn't add anything. And and when it comes to the question of what's behind it all, which is the question of this event, we should explore every possibility that's reasonable, and every possibility that I know of is more reasonable than some specific God based on some specific culture that makes some specific claims, all of which, when you look at the details, have to be argued against by poetic license. Thank you.
Thank you, Dr. KrAUSs. Did you want to say
Sure.
something else?
There's an interesting point of agreement between Dr. KrAUSs and his cosmology and a theistic one. He says that the origin of the universe came about from nothing physical. The quantum cosmological description that he invokes does not provide a cause. In fact, he says it's acausal. Well, theists say the same, that the universe also came into existence with nothing physical. But rather than say that the universe had no cause at all, theists don't want to give up the idea of causality, which is the basis of all scientific reasoning. It's a foundation of science and reason. And so instead they posit the idea that the cause of the universe is non-physical. It has a transcendent source outside matter, space, time, and energy from an omnipotent intelligence. So you have the same physics interpreted in two different ways. And I think the way that it's interpreted by theists preserves a basic principle of reasoning. And so when you look at the big picture, you have evidence for a beginning of the universe, not caused by any known physical cause, fine-tuning, which requires prior fine-tuning in the form of various cosmological models that themselves require fine-tuning, universe-creating mechanisms that require fine-tuning, like both string theory and inflationary cosmology, both require prior fine-tuning to explain the fine-tuning that we see. And then finally, I see evidence of design in the biological worlds that has not been explained by evolutionary theory, but is in fact something that we know, the kind of evidence that we see, the evidence of information, is something that we know that only intelligent agents produce. And so the theistic view of science, I think, is precisely what we see in the natural world, that the universe had a beginning, that has been fine-tuned from the beginning, and that there is information that comes after the beginning, is exactly what you'd expect from a theistic point of view.
Thank you, Dr. Meyer.
Thank
Thank
you.
you. Thank you. Thank you to all our speakers. Thank you to Dr. LaWReNcE KrAUSs, Dr. Stephen Meyer, and Dr. Denis Lamoureux. Thank you to the sites who joined us from around the world and across Canada. Thank you to our sponsors. And please, if you're able, join us now at the reception at Wycliffe College, 5 Hoskin Avenue at the corner of Queen's Park and Hoskin. And you can find out about other religion and society series events at wycliffecollege.ca. Thank you all so much for joining us.